Hi everyone, in today's lesson we're going to talk more about optimization, but now more specifically an example with an open top box. A supermarket employee wants to construct an open top box from a 16 by 30 inch piece of cardboard. To do this, the employee plans to cut out squares of equal sides from the four corners so the four sides can be bent upwards. What size should the squares be in order to create a box with the largest possible volume? So these problems are a little bit different than the ones that we did yesterday because there is no helper equation. So this here, what size should the squares be in order to create a box with the largest possible volume? That's the maximization. So we still need to maximize a specific formula. And if we're talking about a box, or think of it as a tissue box or a box that holds packages, volume, we know, is length times width times height. So that's the formula that we're eventually going to have to maximize based off of our picture. So here, the picture is really very important. So we're basically constructing a box with an open top. So it's a little bit harder to draw, but basically the way that it works is the ends are kind of cut out. So I'm going to use dotted lines to show that it's cut out. So the idea behind it is that the employee started with 16 by 30, but then cuts off these pieces. So if this entire distance, we'll say this distance from here to here is 16, but then I'm cutting off these pieces here, this piece and this piece. We don't know what what those distances are, but they do tell us they're equal sizes. So I'm going to go ahead and assume that this is X and this is X. So if I started with 16 and took out these two X's, this is the distance that I would be left with. And we can represent that by saying 16 minus 2X. So that's what this distance would be here. Same concept goes for the other side. If this is 30 inches to begin with, from here to here is 30, but I'm cutting out X pieces here and here, then this distance is just going to be 30 minus 2X. And you kind of need to use a little bit of an imagination that if these two pieces are bent upwards, then the height of the box would be X. So my length, if I want to call this my length is now 30 minus 2X. So I'm going to put that in for length. My width, we'll call this, which is 16 minus 2X. And my height is X, or the length of the square that I'm cutting out. So I know it's difficult to see this without a 3D demonstration. So the concept really is the length will always be the original value minus 2X. The width will always be this original value minus 2X. And the height will always be X. That's the concept that you're going to need. And we want to maximize this equation, so we know we're eventually going to have to take the derivative. But before I take the derivative, I want to just simplify it. So I would like you to double distribute these two terms first, and then distribute the X in. So take a minute, pause the video, and do that. And then hit resume when you're ready for the answer. Okay, so when you double distributed, you should have gotten 480 minus 60X minus 32X plus 4X squared times this X. I'm going to combine like terms. 480 minus 92X plus 4X squared, and then times this X. And I'm going to distribute the X in. So 480X minus 92X squared plus 4X squared. I'm going to put it, 4X to the third. I'm going to put it in decreasing exponential order. So 4x to the third minus 92x squared plus 480x. So this is my simplified equation that I'm going to have to maximize or take the derivative of. All right, so I'm just going to go on to another page. So here's my volume equation that I would like to take the derivative. So we'll call it V prime. So we get 12x squared minus 184x plus 480. So that's my derivative that I need to set equal to 0. So 0 equals 12x squared minus 184x plus 480. So I'm going to try to find a greatest common factor. I'm going to try to see if I can divide 12 out of both of these. And if that doesn't work, I'll try maybe 6 or 4. So take a minute and find the greatest common factor. Okay, so it looks like the greatest common factor is 4. So I'm going to take out a 4. And I'm left with 3x squared minus 46x plus 120. And I'm going to factor. You can choose at this point to use the quadratic formula. I'm going to factor by guess and test. So we have 3x and x. And I'm going to try the factors of 120. I'm going to try the ones that are closest to each other first. So I'll try 10 and 12. So if I put 12 here and 10 here, let's see if that works. 10 and 36. That'll work. To get 46, they both need to be negative. So this answer, x is equal to 10/3, and this answer, x is equal to 12. So in order to figure out which one of these dimensions will give us the largest possible volume, we have no choice but to do a number line. So here we'll call V prime, and we're going to put 10/3 and 12. So 10/3 is approximately 3.3 repeated, and 12 is obviously just 12. So we have to pick numbers that are smaller, in between, and then bigger. And we're going to plug in to our V prime, which is this equation right here. So I'm actually going to put that V prime into the calculator and find the table of values. And I'm going to test a value smaller than 3. I'll test 0. A number between 3 and 12, I'll test 5. And a number greater than 12, I'll test 15. So take a minute, put that into the calculator, and get me those y values, and hit resume when you're ready for the answer. So 0, I got 480. 5, I got negative 140. And 15, I got 420. So the 480 is positive, then the negative 140 is negative, and then positive. So if we draw our picture, it goes positive, negative, positive. So here is my minimum, and here is my maximum. So they're asking for the largest possible volume, so I want to use my maximum. So we're going to reject this one and use this one. So they want the dimensions for the largest possible volume. So remember, the volume was length times width times height. So I want the length, the width, and the height. So the length was 30 minus 2x. The width was 16 minus 2x. So I'm just going to plug my x value in. So my x is 10/3. And then I will get my length and width values. So take a minute, pause the video, type that into your calculator, and then hit resume when you're ready for the answer. All right, so for the first one, I got 70/3. And for the second one, I got 28/3. So the final answer for the dimensions, the length was 70/3 feet. I think it was inches actually. Sorry, I don't have the in front of me, so I'm going to go inches. By 28/3 inches by the height, which is 10/3 inches. So length times width times height. Those would be my final dimensions. All right, that's it for today. If you have any questions, please let us know.